Assalamu alaikum. Myself Anika, registration number 21TE54. In today's lab, we are going to see the signal representation by using different techniques like scaling, shifting, unit step, and unit impulse. So in the first one, we have to draw the step signal. So first we have used n of 0 is equals to -1. It shows difference of the signal, and the signal is starting from -1. Then we have used n1, that is -3, and n2, that is 3. It shows the limit of the signal. The signal will start from -3 and it will end on +3. And for index representation, we have used this function, that is n is equals to n1 colon n2. And for representation of the signal, we have used this function, that is step. Now we have to run this function. This is our required output, and in this one you can see that the signal is starting from -1, and the range of the signal is from -3 to +3. In the second one, we have n of 0, that is -1. Again we have n1 and n2. It is showing the signal range. That signal will start from -5 and it will end on +5. And for index representation, again we have used this function, and for signal representation we have used the function, that is stem. This is our required output, and here you can see the range of this function is from -5 to +5, and the function is starting from -1. That is our n0. Okay, in the third one we will see the exponential decay in this function. So for that we have used n1, that is -3, n2, that is 3. This is again the range of the function, and it shows the signal start from -3 and it will end on +3. For defining the index, we have used this function, and again we have defined our signal. To represent the signal, we have used the stem function. So this is our output, and in this one we can see that this function is decaying. So this one is the exponential decay, and we can also check the values of x and y. These are some values of x and y, and this is the exponential decay in this function. Okay, in the task number 4, x is equals to impulse 10. We have to check the unit impulse function. So for that, what we have given x is equals to impulse 10, and 10 is the range of the function. Then we have defined our function by using the stem function, and function x is equals to impulse n. It shows the impulse, and n is showing the range of the impulse, that is 10. And after that we have used zeros as in the unit impulse function. The zeros are initialized, so we have used zeros, and the value of the unit impulse is x of 1 is equals to 1. So this one is our desired output, and this one is showing the unit impulse function. And in the next one we have to show the unit step function, and for the unit step we have used x is equals to step, and we have given the range, that is 10. Then we have defined the function by using the stem function. After that, as we are using unit step for the unit step function, we always use ones. So x is equals to 1 comma n, and we have given the range, that is also 1. So in this one, this is the unit step function. Okay, so the next lab task is we have to do flipping of our signal. Basically, the flipping means that we have to shift the signal. If it is present on the positive side, it will be shifted to the negative side, and if it is present to the negative side, it will be shifted to the positive side. Here, the limit of the signal is given range of the signal is from -3 to 3. Then we have given our signal, that is 0 0 0 1 1 1 1, and subplot is used for plotting our signal. To represent the signal, we have used this function, that is stem, and title is original signal. Now here basically we have two signals. One is for original one and the other will be flipped one. For the flipped signal, we have used our command, that is flip, and then again we have used subplot for plotting the signal, and stem to represent our function, and title is flipped signal. So let's run this function. Now we have two signals. The first one is our original signal, that is on the positive side, and the second one is the flipped signal, that is shifted to the negative side. In the next lab task, what we have to do scaling. Scaling means that if any signal that is given, we have to multiply it with the amplitude or the time. So here the signal is given, that is 1 2 3 4 5 6 7. The signal is from 1 to 7. Then we have given our scaling factor, that is 2. We have to scale this function by 2. Then we have used plot for plotting our signal, and as we are doing scaling, so we have used plot scale signal, and at the end we have used legend, original signal, and the scale signal. Again we have two signals. One is our original signal, the other one will be our scaled signal. So the output is this. The original signal is shown with the blue line, and the scaled signal is shown with the red line. In the next lab task, what we have to do now, we have to do shifting. First we have done scaling, now we have to do shifting. We have to shift our signal. Okay, so for that we have given the limit, that is we have given our function, that is 0 10 and 1000, and we have given y is equal to sine of t. It means we have a sinusoidal function. Then we have, as we have to shift our signal, so we have used the command, that is shift, and again we have used plot for plotting our signal. And here also we have two signals. One is our original signal, the other one will be our shifted signal. So the one that is shown with the blue line is our original signal, and the one that is shown with this red line, this is our shifted signal. Now the next lab task is we have to show the zero order hold, and for that we have given the line space for our function, that is 0 1 and 1000, and this is used for the continuous time system. Then we have applied a formula for the frequency. Then we have used another formula, and in this one we have used the sine function. It means that our signal is sinusoid, that is why we have used the sine function. Then we have given the sampling time and sampling frequency, and this one is our time period of the this is the time period used for sampling. And after that we have used the for loop, and we have given the sampling duration, and for that function we have used the zero order. And after that we have used some commands that are basic commands used for plotting any signal in our MATLAB, and like this subplot and plot. Then we have given our title, that is continuous signal, and another title, that is discrete time signal, yet that is used for zero order hold. Now when we run our function, this is our output, and in this one we can see that this is the continuous signal graph, and the down one is discrete time signal, that is zero order hold. After that we have to show another one, which is for first order hold, and we have done the same thing. We have given our input signal, that is 1 2 3 4 5, from 1 to 5. We have given the sampling time and signal sampling. We have given our sampling time, and again we have used different functions that is used for plotting our signal, and we have given the title, that is this. So when we run our function, the output will be yeah, this is our output. We have given the input signal that is shown here, and the output signal is this. That is the basic signal representation that we have seen